translation box. Translation box 405 406 427 okay 453 4782 105 done. The big bird there. Yes, it was 109 494 724. Four three four seven 4015 okay.
Welcome back, everyone. In the last video, we came up with a logical solution to this problem. In this video, we're going to convert that logical solution into a code solution. So let's go back to our tablet. And what I'm going to do is I'm going to show you the general format of how you come up with this code solution. Oftentimes, it's going to take the format of a function, and this function is going to receive the two arguments as its only arguments. And you want to be very explicit about what the name of this solution function will be. So I'm going to name it const find toSum. And the toSum in this particular case is representative of the two numbers in the array that sum up to the target. So it's going to be a function, and it's going to receive our two arguments, the nums array and the target. The next thing that we want to do is we want to think about how to capture what we did with P1 and P2. Remember, P1 starts at the very first position, and P2 started at the position immediately to the right of it. So here what we're going to do is we're going to capture this by creating two for loops. This is actually the easiest way to loop through all of the elements from left to right, starting from some index of your choice. In my particular case, I'm going to start and initialize our first for loop by saying let P1 equal 0, as long as P1 is less than nums.length. Hello, everyone, and welcome to our first interview question. This question is going to introduce our section on arrays, and this is just an easy array question. But this is a great question because it really helps us understand how arrays can show up inside of our interviews, as well as it gives us a good chance to walk through the process of how to tackle and answer these questions. This is also the exact interview question that Google has posted on their YouTube channel to demonstrate how they expect candidates to interview for their software engineering positions. Before we begin, I want to walk through how these questions are set up. What I'm going to do is I'm going to walk through the question and help you understand what the question is asking you to accomplish, and then we're going to walk through the different steps that I have laid out that best help you actually come up with the correct answer, but also interview in the best way during your technical interviews. So first, let's understand what the question is asking us. The question reads, given an array of integers, return the indices. Integers in this case mean that they're whole numbers. They are not decimal-based numbers. The next thing that we're going to receive as our second argument is a target, which is also an integer. We need to figure out what two numbers in the array, if they exist in the array, can add together to give us this target value. In this particular case, when we look inside the array, we see that the values 9 and 2 add together to give us the target value of 11. As per the question, we want to return the indices of these two numbers. And as we know with arrays, indices are going to be the values that represent the index of every value. These indices start from 0 for the very first value, and they increment by 1 for every subsequent value. What this means is that if the answer is 9 and 2, then what are the two indices we want to return? They're going to be the index numbers right underneath them, 3 and 4. So this means that the correct answer for this question is an array containing 3 and 4. So now that we understand what this question is asking us, how do we solve this question? Well, before you even start solving the question, you have to do this first step. And this is a very crucial step that your interviewer is expecting you to do, which is to verify the constraints. Now, what are constraints? Constraints are ways where you can understand the question better so that you know what kind of edge cases you need to consider, as well as all of the different variables that might impact how you solve the question. And this usually comes in the form of a dialogue, which means that you want to ask your interviewer certain questions in order for you to answer and figure out what these constraints are. So let's walk through some great questions for this exact question. The first question that we want to ask is, are all of the numbers positive or can there be negatives? This is a great question to ask when you're working with integers, because depending on whether or not the integers are positive or negative, this changes the approach and the solution that we come up with. In this particular case though, our interviewer may say to us that all of the numbers are positive, don't worry about negatives. So this means that the array we receive, we guarantee that everything is positive. We will never receive an array that contains any negative integers at all. The next question we might ask is, are there duplicate numbers in the array? Meaning, are all of the numbers inside the array received unique or can there be duplicates? In this particular case, we'll say no, there are no duplicates. So this means that when we receive the array, we don't need to account for what happens if the numbers are duplicated. We will never receive a possible array where any of the numbers occur more than once. Another good question that we want to ask is, will there always be a solution available? Meaning, given the array and the target, will we always be able to find two numbers in the array that will add up to this target? Here, the most common answer to this question is no. There may not always be a solution. So the code solution that we come up with needs to be able to figure out whether or not there actually exist two numbers in that array that add up to the target. So this means that we can receive a target of 25. But we might receive an array where no two values add up to 25. But this is not the only possible edge case that this can occur. We might also receive an empty array. In an empty array, there are clearly no values that will add up to 25. Similarly, because we're looking for a pair as per the question, if we receive an array which only has one value, this can also never produce a correct answer for this question. So this is a great question to ask in any question case when we're doing our interviews. A good follow-up to this will be, what do we return if there is no solution? Do we want us to return -1? Do you want us to return an empty array? What do you want us to return? Here, they'll say just return null in this particular case. It's really up to your interviewer to determine what they want you to return if there is no solution. But this just demonstrates that you're thinking about all these edge cases and you're giving that onus on the actual person that's giving you the task to figure out what the constraints are in this particular case. So another question we can ask is, can there be multiple pairs that add up to the target value? Here we'll say, no, only one pair of numbers will add up to the target given. What this means is that if we're given the target of 11, we'll expect that only two numbers in the array will add up to this value. We'll never receive an array where there's multiple pairs that add up to that target. So in the first one, we see that only 9 and 2 add up to 11, whereas in that second array, we see that there's 9 and 2, but there's also 7 and 4. So we don't need to worry about our solution coming up with a case where we need to consider multiple potential solutions. So now that we understand all of these different constraints that we verified through these questions, we want to be able to combine them all together into different test cases. Test cases are just different combinations of the inputs that we could receive, so different combinations of the array and the target that we could get that will best capture all of these different edge cases that our solution wants to account for. This is a process that you can work with your interviewer on, where you ask them, is it okay if we come up with some test cases together that best capture these different questions that you've helped me answer for our constraints? This is what we're going to do together in the next video, but I want you to think about some of these different test cases that could occur from the different constraints that we've just answered. So once you've done that, join me in the next video and let's write out some of these test cases together. Hello everyone and welcome back. In this video, we are going to come up with some of the test cases that will capture all of the different constraints that we verified when we asked these different questions in the last video. So here, let's switch over to the tablet where we're going to walk through and write out these different test cases together. Remember, there's a lot of different constraints that we need to make sure we capture in multiple different test cases. But the first test case that we begin with is known as the best case test case. At least that's what I'm going to call it. And this is a test case that we know for sure what the answer will be for the given inputs that we receive. So here, array and that we return will be 3 and 4, which represent the indexes of these two numbers that we know are the correct answer that when added give us the target of 11. Now, we need to think about those other different test cases, or edge cases, where we might receive an array and a target where there is no possible solution. So let's do that now. The first thing that we want to think of is, let's repeat the same array, 1, 3, 7, 9, and 2, except our target is 25. We know that there's no possible answer inside of this array where there's two numbers that added together give us the target. So what this means is that we want to return null, as per our questions and what our interviewer told us to return if no possible solution exists. Another different edge case that also captures this null case is going to be what happens if we receive an empty array as well as any target value. We can even say a target of 1. In this particular case, we'll also return null because there aren't even two values to add together to find the target for. Similarly, we want to do the same thing where we receive some array with one value. Let's say it's 5, and we also receive a target. Let's even be more explicit. Let's say the target is also 5. In this case, the answer should still be null because we need two numbers that when added together will give us that target. Even though one of those numbers, 5 plus nothing, could give us the target, this is not what the question is asking us. So in this particular case, we also return null. Now for our very last test case that we come up with, maybe we just figure out one where it's low-hanging fruit and a really obvious answer, where there's only two numbers inside of the array we receive, and the target is going to be the sum of those two values. So 1 and 6 added together gives us the 7. In this case, we'll return 0 and 1 as the answer. So this is enough for our edge cases to help us thinking about coming up with a working solution before we get bogged down by any technical details. So I want you to not even think about the code implementation. I just want you to think of a working, logical solution for how you might solve this question if you were just asked this question out of the blue. So if there's no code involved, you don't want to think about for loops, while loops, variables, any of that stuff. All you want to think about is, if I were to approach this problem critically and logically, how would I ensure that I have a working solution that works for all of the test cases that we just came up with? A working solution is way better than a non-working optimal solution. So let's come up with a working solution. How do we make sure that we know whether or not there exists a pair inside of it? Is we would think, okay, if I want to try out every single possible, you would say, okay, with 3 plus 7, doing by keeping track of one number and combination that involves 1. 1 tells us the number that we're testing. P2 is the other number that we're trying out so that we can ensure that all possible combinations that involve P1 are fully tested. Now, how do we know whether or not we have the correct pair? Well, this is where we need to come up with some kind of formula. So here what we can say is that the number to find, which is the number that we're looking for, is equal to our target minus the value at P1. Or in other words, we can say nums at P1 because nums represents our array. In our particular case here, what is the target equal to? It's equal to 11. What is nums at P1 equal to? It's equal to 1. So 11 minus 1 is equal to 10, which means that the number that we're looking for is 10. This is what P2 is going to try and find. It's going to scan through the rest of all the numbers to the right of P1 and see if any of them are equal to 10. So P2 here starts at index of 1. What's the value here? 3. Is 3 equal to 10? No, it's not. So we want to move P2 forward by 1 space because we just tested for that value. Is 7 equal to 10? No. So we also want to once again move P2 forward. Is 9 equal to 10? No, it's close, but it's not 10. So we move P2 once again. Is 2 equal to 10? No, it's not. So we've reached now the end of the array. There's no more numbers to test. What this means is that we know for sure there's no possible solution where 1 is part of the final answer. So what this means is that we are certain that P1 cannot possibly be at this position. So what we do is we move P1 over and we reset P2 as well. So now that we've eliminated 1 from contention, we want to test the remaining numbers and pairs. So P1 is now at 3. So we want to recalculate our formula and say that nums at P1 is now 3. 11 minus 3 is equal to 8. So the number that we're looking for with P2 is now equal to 8. So P2 is equal to 7. 7 does not equal 8, so we move P2 over by 1. That involves 3. Okay, the position at P2. Next step, which is write out this solution we came up with in code. So I want to challenge you to take what we've just done and figure out how to code that out yourself. This is going to be challenging if it's the very first question you've ever done, and this is just good practice because it gets you thinking about how to convert this logical solution into code as the next step. But you've already figured out the logic, so you don't need to worry too much about that. You just need to make sure that the code properly captures this solution. So try this out yourself, and we'll do it together in the next video. Then P1 increments. The next thing to do is to calculate out that number to find. This is where we're going to capture our actual number to find formula. And here I'm just going to say const number to find is equal to target minus nums at P1. So there's nothing here that's different from what we've already written as far as our formula goes. Now what I want to do is I want to initialize P2 with another for loop. So here I'll say for P2, and the initial value of P2 is dependent on the placement of P1. So here I want to say P2 is equal to P1 plus 1 because we're 1 position to the right. And P2 is also going to keep incrementing and scanning through as long as it's less than nums.length as well. And then P2 plus plus. Once we're inside of our for loop with P2, now it's very simple. What is it that P2 is doing? P2 is checking if this current value right here is equal to the number to find. So that's all we're going to do. We're just going to say that if Once we're inside of our for loop with P2, now it's very simple. What is it that P2 is doing? P2 is checking if this current value right here is equal to the number to find. So that's all we're going to do. We're just going to say that if the number to find is equal to nums at P2, the moment this happens, we have our answer. So we can just return an array that contains P1 and P2, which as we know, are just pointing at the indices throughout this array. And this is all we need, because once we found it, we just return it. If this is not equal, we just let P2 continue iterating through the remaining indices inside the array, and we're just going to keep checking those values until we find it. If nothing here is found, then we know that for this current value of P1, it's not going to be part of the answer. So this loop is going to end, and there's nothing we want to do afterwards. We just want to let P1 move on to the next index and continue the same process all over again until P1 hits the end of our nums array. The moment that that happens, we know that at the very least, that this portion of our code contains the solution for if a solution exists. If a solution exists, this part of our code will find it. If it doesn't, meaning that if we received an array that doesn't have two numbers that add up to our target, then when running the solution, we're just going to pass by this double for loop and reach the end here. So if it reaches this part, we know that we have not found a solution. And if that's the case, then we can just return null, because we know that if our code ever reaches this second return statement, there must be no existing solution in the given array. This will also capture what happens if we receive an empty array or an array of one element, because it's just going to pass through this code block as well and reach this final return statement. So here, we'll see that this section actually represents what happens when we receive inputs that have no solution. And that's it. We now have this brute force solution that we came up with without any optimizations, but at least it's a working solution. So once we fully coded this out, you want to take this time to move on to the next step, which is step 5, double check for errors. So here, what we need to do is we need to make sure that we didn't make any spelling mistakes, we didn't make any typos, our variable names are consistent wherever we use them, we want to make sure that all of our cases are correct, we also want to make sure that we're closing all of our loops and we're closing all of our functions if we use them. The main key here is just that you want to do the due diligence check to make sure that your code is exactly how it should be for it to work properly. Essentially, you should be able to copy this letter for letter, word for word, character for character into a IDE and the code should run perfectly. So at this point, this is often where a lot of people get tripped up because they're not used to writing code by hand. Usually we rely on our IDEs as a crutch, and this is why this practice is good, because by practicing and doing this double check for errors, you'll often find that you catch yourself for little mistakes that you would have made if you were using an IDE as well. But the difference is that the IDE catches it for you. Your interviewer is definitely looking for these mistakes, and they're trying to see if you are a careful and cautious coder. So it's important that you double check for errors. Once you see that your code is all correct, then we move on to our next step, which is step 6, to test the code that we wrote. Welcome back, everyone. At this step, what we're doing is we are testing the solution we wrote against our test cases. The reason why this is a very crucial step is because your interviewer is going to ask you to do exactly this. They want to make sure that you understand what every step of the code you wrote is doing, and the only way that they can verify that is by asking you to walk through your solution using one of these test cases. So they want you to keep track of all the variables you're setting and how the code is going to flow and your logic. So this is very important for you to practice, because if you're not practiced with it, you will get stumbled upon having to walk through this code so rigorously. So let's get some practice together. Here you'll see that I've initialized our best case test case. The nums array that we're receiving is going to be this array of 1, 3, 7, 9, 2, and our target is 11. What happens is we're going to walk into our code and we're going to initialize our for loop. Here we're going to initialize our p1 value, which is going to start at 0. Then we're going to move into the next line of our code where we're going to calculate and initialize this const of number defined. This is going to be equal to the target minus nums at p1. Target is equal to 11, nums at p1 is equal to 1, so 11 minus 1 is 10. So I'm going to say ntf for shorthand because I don't have enough space here. So this is equal to 10. Then we're going to move on to our next line and initialize p2 in our for loop. p2 is equal to p1 plus 1. So 0 plus 1 is 1. So I'm going to say p2 is equal to 1. Now we're going to step into our for loop and we're going to do our check. And we're going to see if number defined is equal to the current value at p2. Number defined is 10, p2 is at 1, so this is 3. 3 is not equal to 10, so this ends, and what happens is that p2 is going to increment to 2. So we're going to go back in and we're going to check once again. Is number defined of 10 equal to p2 at 2, which is 7? No, 10 is not equal to 7. So once again, we are going to hit the end of that loop and we're going to increment p2 to 3. 3 is at this value of 9. Is 9 equal to 10 as per our check again? No. So once again, we are going to increment p2 to 4. And then 4 is equal to 2. Is the number defined at 10 equal to 2? It's not. So that means that we are going to try and increment p2 to 5. At this point inside of our for loop, we're going to see is p2, which is 5, less than nums.length. Nums.length is equal to 1, 2, 3, 4, 5. Is 5 lesser than 5? No, it's not. So that means that this loop closes, we reach the end of this for loop, and we now end this iteration. So now what happens is that p1 is going to iterate to 1. So once again, we're going to step back into this new iteration and redo all those steps. So we're going to recalculate our number defined. And number defined here is now going to be equal to the target, which is 11, minus nums at p1 at 1, which is 3. 11 minus 3 is 8. Once we've initialized this number defined value, we're going to step into our for loop again. p2 is equal to p1 plus 1, so p2 here is equal to 2. Then we're going to do our check. Is 8 equal to nums at p2, which is 7? No. Plus 1, which is 3. Is number defined, which is equal to 2, equal to nums at p2? To eat up a lot of your interview by doing this step, but it's a very crucial step for your interviewer to understand an empty array, our nums value of 5. I'm just going to step into our second for loop. We're going to through all of our different test cases using our solution. The next step for us to do is to analyze these spaces. Welcome back, everyone. In the next video, we're going to analyze the space and time complexity of our solution, but now I find it's a good time for me to show you how leak code can help us with our interview prep. LeetCode is an aggregate of all the different technical interview questions that are submitted by people who have done the technical interviews. Here, this is the equivalent question that we just did, which is two-sum. Throughout this course, I'm going to link you to the correct question in LeetCode for each question we're doing. You'll find in your resources folder this two-sum link as well as a link to the REPL that contains the code that we just did. I want you to copy and paste that code into the right-hand side here in LeetCode. Then when you submit the solution, which is that button right here, you will run our solution against every different test case inside of LeetCode. Here you'll see the performance that we've done in our space and time complexity against every other solution submitted. You'll notice that we're scoring somewhere around the 50th to 70th percentile, depending on which one we're looking at. But I want you to understand that these numbers are relatively arbitrary. The percentages and the time and the space will change quite a lot, even on the exact same code being submitted numerous times. It's just a weird thing that they're having problems with on their server. But LeetCode is still a great resource because you'll be able to test your solution against all of their test cases to make sure that your solution accounts for everything. Another great thing is that because it's an active community, every question has that free discussion tab that you can check to see how other people have solved the question, and you can compare your solutions against theirs when you're doing your prep. For a lot of our questions, you won't need to because I will be walking through them so extensively, but it's still a good place for you to get some practice. So now that you understand LeetCode, feel free to use it throughout the rest of your prep, and let's move on to space and time complexity. Hello everyone and welcome back. In this video we are going to discuss step 7, which is analyzing the space and time complexity of our solution. When you're analyzing space and time complexity, you're trying to identify the relative relationship of how much of the time and space resources your code will consume based on the size of your inputs. Meaning that if you have inputs that scale, which they generally always will, in our particular case, the only argument that will scale is our nums array, meaning that this array could get really, really long and really big. How much more time and space resources is your code going to take? What is the relationship between the size of this nums array and the amount of resources your code needs to consume? So when you're thinking about that, let's start with time complexity. With time complexity, you're thinking about how many more iterations does your code have to run if this nums array were to get bigger. So here, when you're thinking about iterations, the main part of our code that has iterations is the two for loops. The first for loop is going to loop over every single element in the nums array. So here you can see that if our nums array grew by 8 elements, then we're going to run 8 additional loops. So this means that this has a time complexity of n. Inside, we have another for loop. And this for loop is nested in the first, which is a hallmark that tells you that combined, these two for loops is probably going to run in O of n squared time. So why is this the case? Well, when you look at this second for loop, generally speaking, there are instances where this loop is going to touch the majority of all of the elements inside of the array. So let's just say that it runs in O of n time. We're going to break this down a little bit further, but for now, let's just focus on the fact that it's O of n. Because for every single iteration of the P1 for loop, we're going to run every single for value inside of this loop. This means that we're running n iterations for every single iteration in this first for loop. So it becomes n times n. N times n is equal to n squared. That's how you end up with n squared for a nested for loop. But you might be wondering, Yihua, this second P2 for loop doesn't touch every single value inside of the array every single time. So why is this still n? The reason for this is because we are trying to identify the relative relationship. When you think about a relative relationship, you're thinking about it relative to the size of the input as it grows. So let's imagine that we had a case where we had P1 equal to 2, and then P2, of course, equal to its next value, which is 3. So here, what you're noticing is that P2 is never going to touch any of the elements to the left of P1. It's only going to touch the elements to the right of P1 in this particular instance. So this is less than half the size of the array, and yet it's still n. Why is that? Well, when you think about it when it comes to this relative relationship, imagine that this array had 4 more elements in it. It doesn't matter what those elements are, but just imagine there were 4 more elements at the back of this. What happens is that this first for loop is going to get 4 more iterations. This internal for loop is also going to get 4 more iterations for every single iteration. What this means is that you are getting at least 4 times 4 more iterations, if not more, because for every previous iteration, loop is going to have this. But when it comes to this relative relationship, imagine that this array had 4 more elements in it. It doesn't matter what those elements are, but just imagine there were 4 more elements at the back of this. What happens is that this first for loop is going to get 4 more iterations. This internal for loop is also going to get 4 more iterations for every single iteration. What this means is that you are getting at least 4 times 4 more iterations, if not more, because for every previous iteration before it, you're also getting plus 4 for all of those n previous loops before, not just the 4 that got added on after. For this reason, you can see how this is indeed a quadratic relationship. So this quadratic just means any value, so n, and then squared. The squared part is the quadratic side of this equation, and we'll talk more about this after. But here you can see how this nested for loop does give us a O of n squared time complexity for this part of the code. Everything else runs in pretty much no scalable time complexity, so the time complexity of our solution is O of n squared. But what about the space complexity? As far as space complexity goes, the only thing that we're doing is we're setting variables, which is P1, and this is a static variable. It doesn't consume any scaling space, and this number to find is the exact same. They're pretty much just pointing to single integers. So this means that our space complexity runs in O of 1 space, which is really good. This is as optimal as it can possibly get. At this point, after calculating your time and space complexities, the question you want to ask is, can I optimize my solution? Here we know that space of O of 1 is as good as it gets. But what about our time complexity? Which different complexities are actually good and which complexities are bad? We know that O of 1 is really good, but what about n squared? Here I want to draw your attention to this chart. You might have seen this chart before if you've done any research into big O notation. This is just a graph that compares all the different complexities against each other in terms of performance, and it's color-coded in such a way that gives you a rough idea of what's good and what's bad. But what I want you to notice instead is actually that anything above n log n, according to this graph, is considered bad. But that's not necessarily always the case. This does give us a good idea in terms of a hint about what's good and bad, but there's actually a different way that we can categorize all of these different complexities. The first categorization is polynomial. This captures complexities such as log of n, which is logarithmic complexity, O of n, which is linear, n log n, which is linear rhythmic, n squared, which is quadratic, which is what we have in our current solution, and n cubed, which is cubic complexity. All of these are considered polynomial, which is better than the alternative, which we'll discuss later. But what makes these polynomial is the way that we can break down what's inside of the brackets. Here, I want you to see that there is a base and there is a exponent. It doesn't always have an exponent, but there's definitely always a base. And this base is always n, which means that if there is a dynamic element inside of this complexity, it's in the base and not in the exponent. What you'll notice is that in the quadratic and the cubic time complexities, these have the exponent, whether it be the 2 or the 3. But what you notice here is that those values are static. They don't change. The dynamic part of the O of n squared and O of n cubed complexities is that the dynamic part is the base, the n. These are all considered polynomial time and space complexities, compared to the alternative, which is exponential complexities. This is where you have exponential 2 to the n, factorial, which is bang, n, and then there is another exponential, which is n to the power of n. In this particular case, all of these complexities scale with the input at the exponent level. The key here is that the exponent is the dynamic variable. Even though you can end up with